quick connector to make it very easy to connect to the machine and to the vacuum pump. We have a gauge. The gauge is a compound gauge, so it gives us a positive pressure and it's going to give us a negative pressure. One of the things that we believe, and again this is just science, it's never been proved, but if there was a unit that was actually very badly contaminated with R40 and that unit had a reaction, maybe in a vacuum. Okay, nobody's ever proved it, it's just theory. But again, by having the vacuum gauge, if we actually saw this when we connect to the machine going into a vacuum, we would stop the extraction. One of the other tools that we can use on this is a sight glass. Here's a sight glass, it's a refrigeration sight glass. It's another tool that we can use so that when we're actually extracting the sample we can actually see if there's any contamination or if we're extracting liquid or oil from the actual machine. So the first thing we do with this is we actually, having established that it's clean, so we've already tested this to make sure there's no contamination in here, we'll put this into a vacuum. This will allow us then to go to the machine, which is in a positive pressure, and when we connect, the positive pressure will push the gas into the vacuum section. So we'll just pull the gas across. So we'll get a very small sample of the gas out of that machine, I'll hold it in here, and then we can bring it back here and test it. Now you might remember yesterday in the presentation, we sort of suggested that it'd be pretty good if you split the two processes. This is a pretty nice depot. You can see it's paved. The sun's out, it's nice. A few helicopters, but that's good. My point is, if this was a really bad, windy, rainy day and you're trying to extract from that unit and in the same place carry out the test, you just might make a mistake and it could be difficult. So the idea of actually just going to the unit, getting the sample, grabbing it, and then coming back to somewhere where this has all been pre-set up, you know, in a sheltered or well-ventilated area, a workshop, or even an office, you know, you can come back and then do your paperwork as well at the same time. I've tested that unit, fill in the form, away you go. John, do you want to take that down? This is a vacuum pump, very common for refrigeration repair shops and depots. Everyone's got one. Okay, that's how quick it went. We're now in a vacuum. There's hardly anything in there, so you can imagine just pulling that little bit of air out there. Happens very quickly. If you remember on the little video we showed, you see the actual gauge kick when we connect. So we're in a vacuum now, you're going to see that go to a positive place, kick up. Just a little precaution that we're actually taking here, which might not be obvious to you guys. We don't know whether this unit is at risk, so we always try to take the extraction while we're standing away from the compressor. We're not actually standing in front of the compressor.
Okay, and I'm gonna open the valve. I'm gonna open the valve on the rig before I open the valve for the gas. Make sure that the unit itself is not in a vacuum. so now you see it's not.
Okay, I can see, sorry, into one side there, John. See the gauge has now kicked up from being in a negative pressure to a positive pressure. It's the same pressure as the machine's at. That little bit of gas that was in there has been extracted into the tube now. That's it, finished. The good thing about this is now you walk away from it. Okay, let's find out if it's good or bad. We were talking yesterday about the Halide flame tester itself. If you look here, you can see inside there's a copper plate. We're actually waiting for that copper plate now to get warm. Okay, once that plate gets hot, when we put the gas through there, if it's got any chlorides in it, it will react with the copper and it will start to burn green. Okay, if there's no chlorines in there, the flame will remain as it is. A sort of bluey colour. That's it.
So how long does it take for the copper when you mean heat hot? So
Usually 2 to 3 minutes.
2 to 3 minutes.
Yeah, approximately. Just warm it up before the test, you know. 2 minutes. Okay. Now what we're going to do is we're going to release this sample down through this very small capillary tube here and into the water. The only reason we have the water there is so we can physically see the gas escaping, so we can see the bubbles. What we want to do is control the amount of gas that is actually being burned. We just want very small amounts.
The bubbles you see coming out of here right now are just air. I haven't actually got it open where I'm releasing gas.
So the flame just changed there, it just picked up the gas that's actually coming out. Very small amounts of gas actually coming up now. The bubbles are just popping, but there's no change in the flame colour. So we know that reefer is safe. That is straight 134A. As we spoke about yesterday, this particular test is very sensitive.